Welcome. This video will be about how to make a pulley. If you want to find things more quickly in this video, look for the transcript. So we're going to make, this is a pulley, and it's going to help guide the power for a car, either a rubber band or a weight. It's going to help move a string around our car. And you can see how easily it rolls. It has a pulley here. That's, let me move this out of the way. It has this part here. It has two washers that keep the pulley in place. And then it has two axle casings that hold the axle onto it. So this is what we're going to make. For this video, it's going to start off with the theory of why this, how this part works, how the pulley works, and then into why we're using it, and then the details of how to actually make it. So the theory behind how the pulley works is similar to our wheels. So if I move the car so that the wheel rotates once, so the car went this far, most of the work done by a large amount of the drag comes from friction between the axle and the axle casing. So this piece of bamboo right there and the thing that holds it. While the car goes this far, the piece of bamboo in the center only moves this far when it's rubbing against the axle casing. So that means you get to move the car this far, while the most of the work done by friction to drag the car, to slow it down, only gets to do the force times this distance. And because the distance is much smaller, the work done by the friction is much smaller, and that allows more of the energy to be transferred into the motion of the car. Now our car is going to use two sources of power. One is a rubber band. So we can stretch this out, have a string attached to the rear axle, and when the rubber band pulls the string, it's going to move the wheels and drive the car forward. It would be possible to just have the rubber band go straight from the front to the back, but there wouldn't be that much distance to stretch it. If we move the rubber band over the top of the car and then down here, we get to stretch it more than twice as far. And we could just use a tube here instead of a pulley, but you can maybe see from here that there's a lot of friction between the rubber band and that piece of paper. If you just had the string passing over it, there would be less friction, but also you'd have a lot less stretch in the rubber band, and with less stretch, less energy to put into it. And the other way that so that's for our last formative. For our summative, we're going to be using a falling weight. And without a tower like this, there'd be no way to have the weight fall. And again, we could have the weight just going over a paper tube like this on the top. But a lot of work would be done dragging the string over that tube. So by using this pulley, most of the work from friction is going to be between this thing that holds the axle and the axle itself. The parts we're going to need two of these tubes. The tubes are going to be made from a strip of paper like this, which has a place with graphite in it that's slippery, and we can fold it around the stick to make a pocket. That pocket is very important because it will keep this tube from grabbing the axle. So imagine that the paper inside the tube is like your hand. If it grabbed your hand, it could wrap very tightly, even if it starts out loose. But if you have a folded over place on the inside, it's not going to be able to grab the paper on the inside as easily, and it's not going to be able to close the tube. So if my tube is kind of like this, that axle isn't going to be able to bring the edge of the tube, the inside of the tube, into the center. So that's why having this fold is so important. A lot of people forget that, and then their car all of a sudden just comes to a stop because that edge of that paper just grabs the axle. So you'll need 2 of these, and I'll show you how to make those. Two washers like this. They don't have to be so neat. You could just cut a square or a triangle, and that would work just as well. 1 of these, and 1 axle. The axle should be just a little bit longer than the place where you're going to mount it. Now, since for the final I'm going to be dropping a weight down here, if you can see on my car, I have this paper tube could kind of get in the way of the weight falling down. So I'm going to move it from the front to the back. This part here I'm not worried about because I could just limit how high I raise it. And also the axle, well, if I limit the height of my weight from here down to here, I can still leave this top tube in place. And I'm going to leave this here because if I remove this, this could really make the car a lot weaker. But I am going to remove this tube. So first I'm just going to kind of prepare the car. So I'm going to melt off as much of this glue as I can so I don't damage the car. One of the advantages to using hot glue is that you can heat it up to make adjustments. So I tore the paper a little bit. And just going to put a little bit of glue where the paper broke away to make sure it's not too much weaker than it was before. Try to be more careful with the hot glue than I was just there. Also, be very careful to avoid getting hot glue on any of the moving parts. I'm just going to put the reinforcement onto the back where it won't get in the way. Another option is you could cut this and then I could put it more neatly right between these 2 poles. So that would be another option. And remember that hot glue isn't isn't very sticky. Especially over time, it can easily detach from something. So to really make sure it stays in place, it's important to have just a little bit wrapped all the way around the structures you're trying to connect. In this case, I already have that layer of hot glue wrapped around here, but I'm just trying to point it out again so that you can kind of see the idea. So I'm just making sure that there's a little bit of hot glue that goes all the way around the part being connected. So now I'm going to figure out how I'm going to attach it. I want this part to be straight relative to the axle down here. And you can see my tubes aren't aligned perfectly. So when I put my axle in place, I'm going to have one part a little bit back and one part forward. And it's a good idea to, if you're doing something like that, you can make a little bit of a mark so you know where you want to attach it. You could also even add some more paper or another tube if you needed to get the length matched. But I think I can mount it just by having one axle holder or axle casing on this side a little bit back and the one here a little bit forward. So that's how I'm going to do it. And then now that I move this part here, you can see that the weight can drop all the way down. So this is a very important consideration for your car. Also, when it reaches the bottom, there should be something to catch and hold the weight. I might have to put a piece of paper over here because otherwise the weight could fall through there. I might as well do that now. So I'm just going to put that paper like right there, and that should give a place to catch the weight. This doesn't have to be that well attached. If it comes off, I can just put another one in its place. But that's so that for the summative, when the weight goes to the bottom, the car can catch it. And you'll use a string, not a rubber band, for the falling weight. Using the rubber band could make things more complicated. Okay, so I made the preparations to the car. Now I'm going to make an axle casing or axle holder. So I'm going to make another one of these. And I'll guide you through the process for making it. So you figure out how wide do you want it. So in my case, I figured 20 millimeters or 2 centimeters was wide enough. So I measure out 20 millimeters from the edge of a piece of paper like this, and then do the same thing on the other side. So I measured 2 centimeters from the edge here, and then I'm going to draw a line. It looks like I was a little bit off there. draw a line that this line is now 2 centimeters consistently from the edge of the paper, so that makes it a rectangle. And then you fill in, might as well do it just to give a good example. For this part, you're going to make a slippery place that's going to hold the stick in the center. And then once you do that, you just cut this and then you get a strip like this. And you put the stick into the pocket so that you can roll it. So you can see how I folded this part around the stick. And you want to make sure the slippery part stays in the middle. I also made 2 marks at the end that are 1/2 centimeter apart. This is so that when I get to this point, I can let the paper slide just this far to increase the inside by this distance divided by pi. So this distance is about 5 millimeters. If I divide by pi, I'm going to get something close, a little bit less than 2 millimeters is going to be the increase in the diameter, which allows this to move very easily around the axle. So now that I put this stick into the pocket, I'm going to roll it up just like we did all the other tubes. It's tough to get this started because it's that center of the pocket is slippery, which is a good thing. It's going to make our axle holder work better. And I'm going to roll it tightly just like we do any of the other tubes until I get to these 2 marks that I made. Once I get there, I'm going to, instead of rolling it, I'm going to slide it over. So I've made a little bit of space. You can kind of see that back there, how there's a little bit of space. And you can use either tape or a little bit of glue. I'm going to use a little bit of glue. And I need to be very careful to make sure I don't, that space in the center doesn't get glued together. So I want to make sure that the glue is only on the outside of the paper, because I need this center part to actually loosen up to make for this to work well. And if you can think about which way the paper is curling, so in this case the paper is curling around this way, I want to, like the same way I would pry my fingers open, I want to do the same thing to the paper. So I want to twist the paper in this direction the same way that you would use to open the fingers. So imagine that the curl of the paper is like a pair of fingers and you want to open them up. So that means I want the outside to move this way and the inside to move that way, and that will open up the paper. And that's why I have these 2 pencils, is that can kind of, you can actually use those to grab the inside of the tube and then twist in the direction that you want to twist. This is easier if you have someone in your group helping you out. And when you're done, you should have an opening on the inside. And it will be, it's possible for this folded part to still get grabbed by the axle, but not as easily as if you just had the paper just rolled normally. But you can make it more secure by making sure you get that double fold pressed against the side of the tube. So if you can get that to lie flat, that will make your axle holder a lot more secure. So now I have my 2 axle holders that are going to go like that. Except in my case, one's going to be a little more forward and one backwards so that they're straight with respect to the rear axle of the car. Now the other part, I need two of these washers. A way that you can make a circle is you can use anything that's round and about the size that you want, and then just trace around it. But it doesn't even have to be a perfect circle, and since to make this video no longer than it has to be, I'll make the shape a little rougher. So this will still work even though it's not a perfect circle. And I'm just going to put a hole in the center. Now, one thing that's important to consider is one side of this washer is a little bit rough because the edges of the paper are on one side and the other side is smooth. You want to make sure the smooth side is going to be the side against the axle. So it should be like this and not like that. I don't want the rough side catching the tube because that could suddenly increase friction and make your data noisier and less consistent. So now I have my 2 washers and my 2 axle casings, my pulley and the axle. So these are the parts. The way they're going to go together is we'll have the pulley in the center. We'll have one of these pieces of paper on the other side, but the rough side needs to be facing the center of the pulley, so that's why I swap them around like that. So with this one, I don't know if you can see on camera that the rough side is there, so I'll make sure the rough side is facing the pulley, so that the smooth side is on the outside. And then those 2 pieces of paper are going to keep our pulley in the center, or it's going to keep the axle from moving about. We have a similar thing with these rear wheels, and the wheels are doubling up as these washers that are holding that center part in place and keeping the glue away from the moving parts. So now that we have everything, all we have to do is attach it to the car. When attaching the axle casings, you want to make sure you have the axle already in the casings because that will make sure they're aligned. If I had these out of alignment and then kind of forced them to line up, that would put a lot of pressure between the axle and the tube. And the more force that you have pushing things together, the greater the friction force between them. So to keep the friction forces as small as possible, it's better to have the axle already in there. It also makes it easier to assemble. So I'm just going to put this like that. And to make this a little bit easier, I'll put down the glue first, and that will help hold this in place. I can even use the center of the tube to help grab the glue, so I'm going to make sure some of the glue is squeezed into that center. And I'm also going to put a ring of glue around the outside. Doesn't have to be very thick, but just a little bit, because remember, the hot glue isn't very sticky. It's stronger than it is sticky, so if you have it wrapped around the parts, it's going to be a lot more secure. And now I just need to try and align this up so that it will be I want my axle and the axle of the back wheel of the car and the axle of the pulley to be parallel to each other. And then I also want to make sure that the tubes or the axle casings or axle holders are also aligned with the axle. Once I have things in place, I'll add a little bit more glue. Can also help to try to kind of align one tube at a time. So I'm trying to make sure that the tube is also parallel to the axle, so that there's not going to be any extra forces between the tube and the axle. And that will help it move very freely. And it looks reasonably, the alignment is reasonable, that they're both moving somewhat parallel to each other. So now I'll apply the hot glue to the other axle case. And again, make sure it's lined up. If it's real cold outside, you can hold it near a window, and that will help it cool down more quickly. So once you have your axle casings in place, I should give this just a minute. I'm actually going to take it off screen and hold it near a window so that the glue cools. Unfortunately, the hot air in the building seems to be blowing out of the window rather than letting the cool air in, but it's still, I think it's cooled enough so that I can work with it. So now just going to adjust these washers so that the axle, there should be just a little bit of space so that the axle casings aren't being pressed against these washers and it can move freely. And now that I have those in place, I can put just a little bit of, just a drop. Hot glue is all it takes to keep those in place. And you need to make sure that all of the hot glue is on the inside and not, it has to be, the hot glue has to be between the washers and the pulley in here. If any of it gets out here, then it can, it's gonna increase the friction that you're trying to reduce. So once I have those washers in place, I'm just gonna try to center this so that it's directly over the back wheels. Specifically the handle that's going to deliver the power. So I want it right about here. And again, we're going to use a string, not a rubber band, to hold the weight. That was available. So just making sure that this is lined up, and it seems to be. I know it doesn't look centered here, but the important thing is that it's centered above the rear wheels. So if the tower is curved a little bit this way, it might mount it it might look off center on top, but you want to make sure that it's centered relative to the bottom. And that actually should be even a little bit more this way. So my tower slanted a little bit in that direction. So that looks that's about centered. So once you have the pulley so that it's directly between your rear wheels in what's called a plumb line. So plumb means lead. So plumb line is literally if I'm hanging a weight, the direction that weight hangs. And I'm going to grab a longer string that will help demonstrate what I'm talking about. So this is what you'll be using for your summative. Is we'll have your weight on a string like this, and part of it will be wrapped around the rear wheel, and as the weight falls, it will put a twisting force or a torque on the rear wheels that will turn them and make the car move. But this is a plumb line. So if I hang a weight from a string, the string will always line up with the center of our planet, or at least the center relative to the gravitational force that can be affected by our spin around the planet and some things like that. And so according to the plumb line, that's how I want to align the pulley. So I want the pulley to be in the center compared to that plumb line. Actually, it looks like maybe the center is over here, so that's where I want my pulley. I'll do just one more. Check. Okay, that looks fairly well centered. So once I have my pulley right above the rear wheels, I'm just going to put a little bit of hot glue to hold it in place in that position. Also, if you use too much hot glue, this part can melt. So be careful not to melt your pulley. Make sure it's still in the right place. Good. So now this is ready to roll with power. And the way this will work is you can kind of hook the string here, and then it wraps around the axle. You want to make sure that the string, when you're wrapping it up, should stay around the thicker part, your handle, so that it has more leverage. And then you attach the other end of the string to the weight. And as the weight falls, the wheels turn. Now this string is way too long for this car. You want to make sure that when the weight is at the bottom of its path, it should let go of that hook. So the right length for this string would be this long, and I could, this is actually for another person's car, so I'm not going to do it, but I could tie it right there, and then I would have a string that was just the right length. Or another place, and this can avoid tightening it up, you could use a bit of hot glue. The benefit to using the hot glue, if I tie a knot, I'm actually going to make this a little bit shorter, whereas if I use the hot glue, I can get it to be just the right length. In fact, it won't take that long. I will set up a demonstration with the hot glue. I'll pause the video just for a moment. Okay, so I have this string here, and I'm going to make a simple loop just by tying a knot with the string folded over. So now I have a loop at one end. I'm going to trim it. So I'll use this loop to hold the weight. And I want the other end to be just the right length. So when the weight is at the bottom, it will let go of the rear of the drive wheel. I shouldn't say rear wheel because depending on which way, in fact I'll do it for this demonstration, if I wrap the wheel in this direction so that it's pulled this way, that will actually make it front wheel drive. But first I need to make that loop. So what I'm doing here is I'm wrapping the string around that hook and making it tight so that this way the string will let go right when it gets to that point. So now that I have that point, I'm going to take just a little bit of hot glue and just put just a drop of hot glue right around on the string right there, just to hold it in place. Let that cool down. I'll see if I have any luck with getting cool air through the window to make this cool faster. No luck with the window. I'll just pause the video for a moment while this hot glue cools. Alright, so now that the glue has cooled down, we should have, I just need to cut off the excess string. So there's, you can see a little bit of more string than I need over here. That's the excess string. So I'll put the end around the weight is the strength of that is more critical, so I use the tied part of the string there. The part around the axle doesn't, for most of its travel, it's going to be largely supported by the handle, so it doesn't need the strength as much. And also if it breaks, it will generally be when the weight's all the way at the bottom, so you don't need to worry about it. So I'm going to hook the weight to the string, and I told you I would show you this front wheel drive, so I'm going to wrap it so that the weight is pulling the wheels this way, so that will actually travel in the direction of this rear axle. So this is the front wheel drive configuration. Now I can adjust the amount of energy here by just deciding how high I want the weight to be. The height of the weight is from this lowest point to the bottom of the weight. So right now, if I want to measure the height, I could just use meter stick. It looks like it's about maybe 88 millimeters is the height. And so I would have 88 times, in this case it's a 50 gram mass, times 9.8 meters per second squared from gravity. That will give me the energy that's stored in here. And you can see how my car is actually moving that way. That has to do with how the string is wrapped around the axle. And when it gets all the way down to the bottom, you see how it lets go of the string. This is what you want, is you want the car to be able to keep moving. So you can look at how far it goes, and that will let you know how much work was done by drag, because you can multiply the total travel distance times the work. And having it carry the mass with it means the mass is constant for the entire run. So you have a much simpler system. If we didn't have something to catch the weight and the weight fell off, that would change. You'd have to actually calculate a different mass, and however much energy this weight had from its speed when it hit the ground would also be lost, and it'd be much more difficult to calculate things. There's one other thing to do, just so that you're considerate of the space to the cars next to you. Your cart should be no more than 12 centimeters wide, and so this extra spot, you need to trim it. I cannot use those scissors because they're not designed to cut bamboo. I should have had this out as needed parts. So I'm going to use these pliers, have a part that's meant to cut this. Also, when you cut it, you want to either make sure you could hold this over the trash, or make sure someone is holding it, because otherwise this part can shoot away. We don't want to hurt anyone. So in this case, I'll just hold that here. While we're talking about safety, one other thing that you can do is to protect yourselves and others from splinters. Put a little bit of hot glue just around the very end here, and this will help reduce splinters. If you can see, I did the same thing to the axles. There's a little bit of hot glue at the ends, and that's just to make the car a little bit safer. I hope you enjoy it and do well with your summatives and also your formative. And that's a wrap. This is our pulley, and it's making the transfer of power from the axle to either from your weight or your rubber band to the axle a lot more efficient by reducing the work done by moving the string or rubber band over the top, because the work is force times distance, and the force is being applied right in here between the bamboo and the axle casing. And when the string moves from here to here, this bamboo only moves about this far. So that makes this more than 10 times as efficient as if we were just had the stick instead of the pulley, and much more efficient than using a piece of paper, especially when you get to the rubber band, which would actually grab here, whereas with the pulley you can see how easily this rubber band slides back and forth. You can see I can't really move the car much by sliding the rubber band back and forth, whereas if it's on the paper, it's very easy to do that. So that's the pulley. Make sure to ask me or my fellow teachers if you need any further assistance with this. Thank you very much.